Hoping to get rid of that bar down below. Can't seem to do that. Okay, I have to leave it. Right, tēnā koutou katoa. I'm here to talk, as Anne said, talked about the eclipse that's happening this Friday. So I'm going to just not talk about lunar eclipses, but talk about eclipses in general. And I'll try and keep this as short as possible. Okay, so talking about lunar and solar eclipses. And essentially, we're talking about three bodies there, which is the moon, the earth, and the sun. We got light from the sun, and the shadow it casts, like on the top there's the lunar eclipse, so the earth's blocking the light going to the moon, and we have an eclipse there. And also with solar eclipses, the moon gets in front between the earth and the sun, and that blocks the light and creates a shadow on the earth. And I'm not going to talk about the third scenario, which is that one. So by now you would all have heard that there's an eclipse this Friday, and we'll be up at Space Place with our telescopes, and they'll have their telescopes out there too. Now, the eclipse actually starts happening around 5 o'clock in the afternoon, I think. I've got my notes somewhere. Yeah, 5 o'clock in the afternoon is when it starts, but we won't actually see it till about 7:40 when it starts to rise. The moon is actually rising at 7:40 in the northeast. And that's where we'll actually see the moon already in its totality. So we'll see a red moon coming up then. And it'll end around 11 o'clock at night when the full moon will be out of the shadows of the earth. And it will last about 3 hours, 20 minutes. This is a map of where the eclipse will happen. Basically, all of North America and South America will be able to see it completely. New Zealand is on the edge there, so we don't get to see it completely, but we do get to see the totality. Other countries like Australia won't get to see the whole totality or even part of the partial eclipse. Some of Europe might be able to see it, and some of Africa might be able to see it too. So what's a lunar eclipse? Well, as I mentioned before, we've got the sun, 150 million kilometres from us. We've got the earth, and we've got the moon. And what happens is the earth creates a shadow, and the earth moves within that shadow. So we've got the kind of outer shadow, which is called a penumbra, and as the moon enters into that, it will start to darken a little bit, but it'll still be quite bright. And then finally, it will go into the umbra, which is the actual dark shadow of the moon, of the earth. And that's when we start to see partial eclipse happening. And then when it finally enters the whole shadow, the umbra, we'll start to see it as a totality. So that's the lunar eclipse. Now, lunar eclipses in general, you can get it so that you will see a partial eclipse, or you could see a penumbral eclipse, but without a totality. It depends really on the location of the moon and where the moon is as it passes through the shadow of the earth. And this is going to be what really happens in Wellington. So we'll have the penumbral eclipse starting at 5 o'clock, and around 6 o'clock, there's partial eclipse starting. We won't see anything till then. And then the full eclipse starts, and then soon after that, we'll see the moon rising up, and it will be red in colour already. Maximum occurs around 7, 8 o'clock. And then we'll start to see it become partial eclipse turning up then, and then the penumbral eclipse after that. So essentially by that stage, you'll get a slightly darkened moon, but not, nothing really to rave home about. And it finishes around 11 o'clock at night. So this is what we'll see, hopefully, on a nice clear night. The weather forecast at the moment is a little dodgy. It's going to be a little bit cloudy, but I think we'll still get good views. So, it'd be definitely worth coming out and having a look. Even if you're not coming out to the space place, just standing out at home and looking at it, you'll see the red colour in the sky. You need to look northeast and get a good view of it, because it won't, by the time, I think it only rises to about 10 degrees is when the eclipse starts to change into the partial eclipse. But that's a picture that Matt Malcolm took, and I'm pretty sure he took it on the Mars Cretny Observatory, so it's quite a remarkable picture. But the question we want to ask is, why is the moon red? If it's actually going into the background of the Earth's shadow, why do we see it as red? Well, the answer to that is the light from the sun passes through the Earth's atmosphere and it gets diffracted. So this is called Rayleigh scattering. So the particles in the atmosphere break it up. And so it's like a prism. And so we get the red light bending back down and bending it on the moon. So essentially that's the sunlight, the red part of the sunlight being refracted onto the moon. And that's how we see the moon as being red. Whereas the other light, the blue and green, gets scattered out to space. There's actually a scale for the brightness of the lunar eclipse, and it's called a Dajon scale. So you can go from 0, which is very dark eclipse, to a sandy copper red color, orange. And the reason why we have these different colors is purely because of the Earth's atmosphere and what's going on in the Earth's atmosphere. So it's nothing to do with the moon, it's nothing to do with the sun, but purely just the refraction of the atmosphere itself and what's going on. Like if you had a volcanic eruption, for instance, creating a lot of particles in the sky and in the atmosphere, you probably get a really dark, really red moon shining out. This is to show from Wellington itself what the eclipses are. So we've got the one that's coming Friday. There's another one in September, which is another total lunar eclipse. And a fortnight later, we have a partial lunar solar eclipse, which we'll be able to see in Wellington and across New Zealand. And then some more eclipses into 2026. So there's the main ones to look forward to. There's the September ones there. Now, I mentioned that we've got an eclipse on the 14th, which is a lunar eclipse, but that's actually associated also with a partial solar eclipse, which happens a fortnight later. And that is going to be a high up there near Greenland in top part of the States. And it's only a partial, so you won't actually see a whole total eclipse, but you'll see part of the sun cut out by the moon. Now, when you think about it, why do we have these partial eclipses, lunar and a solar eclipse together? They're in a line, right? Everything's lined up. So we'll have a lunar eclipse, and then the moon will go around the Earth, and basically it'll create a shadow on the Earth, and that will be our solar eclipse. So, quite often they come in pairs like that. Just going to jump aside and talk about solar eclipses. So on the left there is the partial eclipse. So the moon doesn't cover the sun completely, so we get a partial eclipse. We can get an annular eclipse, which is the moon is actually smaller than the sun and relative to the sun. So then we get this ring of fire around the moon. So that's an annular eclipse. And we can also get a total eclipse, which is the moon completely covers the sun, and we get this dark or red, dark totality of the shadow on the Earth itself. So here's the total lunar eclipse, and you can notice there we've got the penumbra and umbra there, and you can see that the umbra touches the Earth there, and it creates a path of totality along the Earth, and that can last between 2 to 6 minutes. So it's quite short, whereas lunar eclipse can last several hours, like 3.5 hours, 4 hours. So that's a total lunar eclipse. Then we have what we call an annular solar eclipse, and you can see now that the umbra doesn't actually touch the Earth itself, and that's because the moon is further out. So this is where we get the ring of fire, which is an annular eclipse. And then, of course, if the moon isn't quite lined up with the Earth, but it enters it creates an umbra that actually casts a shadow on the Earth, that will give us a partial eclipse. And that's what's happening on the 29th of March. There's also a fourth eclipse, solar eclipse that you think about. This is called a hybrid solar eclipse. And what happens there is essentially you have an annular solar eclipse happening initially at the start. And because of the curvature of the Earth, that umbra then touches the Earth. So you get a total solar eclipse. And then as the moon moves around, it goes back to an annular. So it's a very rare event. So I don't know how many people in the world actually get to see that. And I haven't actually looked up to see when the last one was, but very rare indeed. And that's just some images there to show you what a total solar eclipse looks like, which is the one on the left, and an annular ring of fire one on the right. Now, the reason we have these annular solar eclipses or a total solar eclipse is because the moon is actually traveling in an ellipse around the Earth. And we have a point where it's closest to the Earth, which is called the perigee. And we've got a point which is furthest from the Earth, which is called the apogee. And depending on the position the moon is when the eclipse happens, determines whether you have a total solar eclipse or an annular solar eclipse. So there it is, just to describe it. So there's quite a bit of distance there between a perigee and an apogee. And so that's why the moon appears a bit smaller in the sky during an apogee, and we have an annular eclipse instead. There's also a thing called the Saros cycle, which happens roughly every 18 years, just over 18 years, or 223 months. And essentially, it's the same eclipse repeating itself every 18 years or so. So you can see there in 2009, you've got that path, and then 2027 is a similar path, 2045 another path, and they're all the same, essentially the same eclipse. So there's a cycle there that takes place every 18 years when the moon is back in the same position relative to where it was 18 years ago, roughly. So you get that. And because we're getting these solar eclipses, obviously that follows that lunar eclipses will do the same thing. So every 18 years, if you have a solar eclipse happening now, or Friday, 18 and a bit years later, same thing's actually going to happen again. And so this is the Saros cycle that's happening there. And there's again a picture of this is like a ring, diamond ring type eclipse. So you can see a very bright part. So, Warwick, you've been to a solar eclipse, right? Yes. Anybody else has been to a solar? Andrew, there's a few. Oh, good, John. Yep.
That's the goal to see. Let's take it off the start of the eclipse.
Yeah.
So you have to see it for a second. Just a little bit of sunlight through the valleys. First of all, also the sign of the glass.
Okay. I looked up to see where the first records of eclipses are. And apparently the first lunar eclipse was recorded in a book called Zhao Zhu, which is the Chinese writings, and it was discovered around 250 BC roughly, and it talks about a lunar eclipse going back 1,000 years or so, or several hundred years prior to that event. So it's written in that text there. In solar eclipse, there's a mount, I think it might be a burial mountain island, and there's a carving there on a stone in that mount, and it sort of depicts concentric circles, which kind of, people are thinking that maybe that's actually the solar eclipse. So the record goes back over nearly 5,000 years ago about recorded solar eclipse. There's a tablet that was found in Syria that talks about eclipses in something like 1300 BC or 1200 BC, then that's actually recorded in there. So, if this isn't a solar eclipse, then that's our next best record is about 1300 years ago. Right, the title of my talk was, the miracle of eclipses. I was going to title it The Magic of Eclipses, but given the eclipse and its tie to the occult, I thought we'd better stay away from that. So I called it Miracle instead. And think about it. We're on a planet. We've got a moon orbiting. Now, how many, we've got a galaxy that's got several hundred billion stars. How likely is this event going to occur elsewhere in the galaxy? Is this quite unique, or will we see this repeated in other places? And if you think about the Earth and Moon, it's almost like a double planetary system. We've got a dead planet, or a dead object, which is, no atmosphere, nothing. And yet we've got another planet orbiting each other, which has got life on it and water. So, how many of these will we see in the galaxy itself? So is this really unique? Well, the question you want to ask yourself is, okay, we have full moons and, regularly every month. Why don't we have a lunar eclipse every month. And the reason for that is because essentially they don't line up all the time. I should talk about this first. The moon orbits the Earth every 27.3 days, okay? So it goes around once around them. But it actually takes 29.53 days between new moons. Does anyone know why? Vicky knows the answer. Murray knows the answer. So essentially what happens is you've got the sun, you've got the moon, and the Earth and the moon. And what happens there is it takes 23 days to go around the Earth, but in that time that it's going around the Earth has actually moved across in its orbit around the sun. So the moon has to take a little more to go around to be in its relative position again for the new moon. So it takes another 2 extra days to go around. So it's actually going 29 days before it in its same relative position. And that's where we get the 29 days from. So the moon orbits about 12 times a year, which is where the word month comes from. But the moon is also tilted at 5 degrees to the Earth. So that's the reason why we don't get a lunar eclipse every month. And in fact, there's 2 points where it would line up with the sun. And those 2 points that line up have to be lined up with the sun itself to get lunar and solar eclipses. So they don't happen that often. In fact, we get lunar eclipses roughly every 2.5 years, and solar eclipses every 2.5 years. So the last one, the picture I showed you, the map took, was actually in November 2022. And that was the last time we had a total lunar eclipse. So this is the reason why we don't have regular eclipses. So, having that tilt. So it makes it a bit of a unique experience. Otherwise, if it what happened every month, I think we'd get bored with it very quickly. The other thing is that's a real picture of the Earth and the moon. And you can see how far apart they are. It's something like nearly 400,000 kilometers apart. And so, and you talk about the sun being 150 million kilometers away, 150 million, yeah. And then all these 3 objects have to be lined up. They're relatively small compared to the distances themselves. And you want to line them all up. So even if the moon is inclined by 5 degrees, you can see that it can quite easily miss the shadow of the Earth. And believe it or not, you can take all our planets in the solar system and stick it in between the distance between the Earth and the moon and still have about 8,000 kilometers to spare. Yes. Probably won't even have an Earth left. So, how big is the moon? Well, it's actually slightly on the size of Australia. So if you want to compare the moon with Australia map, you can see that the moon is actually about the size of Australia. And some other facts there, like you can get 4 moons across the Earth. It would take about 50 moons to fill up the Earth. But if you weighed the moons, you'll take about 80 moons of mass compared to the mass of the Earth. So that straight away tells you that the density of the moon is a lot less than that of the Earth. But the unique fact that I really wanted to point out is this one down here. The moon and the Earth are relatively the same size in the sky, which is quite a coincidence, really. Turns out that the moon is 400 times smaller than the sun. The sun is actually 400 times further away than where the moon is. So to us, they look roughly the same size in the sky. And that's why we get these total solar eclipses and annual solar eclipses, because they're about the same size. So again, that's quite unique and quite a coincidence that we're living in a time now that this is happening. There's going to be a time in the future because the moon is actually moving away from the Earth. It's moving roughly about 4 centimeters every year. So over time, there's going to be a point where we won't get total eclipses anymore. All we'll be able to see is annular eclipses as the moon moves. But that's, I think, hundreds of thousands of years into the future, so nothing to worry about for us right now. So how was the moon formed? Well, the moon wasn't always there. When the Earth formed about 4.5 billion years ago, there was no moon. And it was about 160 million to 175 million years later, after the Earth formed, that the moon got formed. And it got formed because a planet-sized body, like planet-sized body, crashed into the moon. This body is called Theia. So it hit the moon, caused both planets to basically not vaporize, but liquefy, and shot up a lot of materials up into space. And that's how the moon formed. I'm going to show you a video now of what the simulation of it, and this is something that came out of NASA not too long ago, so it's pretty up to date. Now, originally, when we had this theory of this object there hitting the Earth, talked about debris going out into space and forming this ring of debris, and eventually over hundreds of thousands of years or millions of years, they coalesced and formed the moon. But this current simulation shows that the moon actually got created in a few hours. So once, there was a day when there was no moon, a few hours later, there's a moon in the sky. But there wouldn't be anybody around to actually have seen it at that time. So the Earth would have been a big molten ball of material. Now, when the moon got created and got formed, it was only about 20,000 kilometers away from the Earth, so it was very close to the Earth. It was huge in the sky. At that point also, the Earth was rotating about 5 to 6 hours a day. So one revolution is 5 to 6 hours. So you can imagine, in terms of being on the Earth at that point, how fast, and you're having these massive winds. And there was also, because the moon's so close, you have these massive tides. In fact, the tides were rushing around the Earth were 3 kilometers high. So you imagine them, these going around the Earth regularly because of the gravity of the moon or the pull of the moon. And what the tides did was wash a lot of the material off the land, took a lot of nutrients into the sea. And that's how they think maybe life got formed, is because all those nutrients from the Earth actually went into the sea, and life was able to, get created, involved in the oceans. So when you think about it, the moon, there was one point in time there was no moon, all of a sudden we had a moon, we had these tides, and life got created. So in some sense, if we didn't have a moon, would life have been quite different, and would have life have taken place on the Earth without the moon? So it's kind of ironic that we're here looking at the moon and seeing the eclipses when the moon itself could have been responsible for creating life on the Earth and creating us. And here we are, at a point in the evolution of the Earth and the human species that we can actually see eclipses. So to answer your question, there's a lot of coincidence, a lot of things happen there that makes it quite a fascinating. We can go out and have a look at the moon or an eclipse, but a lot of things have happened in terms of geological scale. They actually allowed us to be at this point in time to be able to see the moon, see eclipses. And again, on other planets, around other stars, around galaxies, and would you be able to see something similar? maybe this is quite a unique place to be. We could get a lot of tourists one day coming to see eclipses. I got asked by Chris Monaghan, who's sitting right here, to put this picture in, so I'm just putting it in just for his sake. Me holding the moon. So thank you all for listening.